Okay, lesson 23, orbits and satellites. So if you haven't already watched the intro video to this, go ahead and do that. It's pretty neat actually. It's a cool little TED Ed video that shows you why things actually orbit. Um, Moving on from that though, so if we kind of think about this picture here, let's say this is actually Newton came up with this kind of conception, right? So with projectile motion, we've been doing problems where if I shot this thing at an angle like this, it'll eventually come down here, right? But really, when we're talking about orbits, all we're really talking about is the same type of thing, but instead of a flat ground, we've now got an Earth that's below you, right? So the same thing. So what keeps happening is that the projectile made its path, but then there's no Earth there for it to hit, right? There's nothing there. So it just keeps on going. And then it'll go around again and then miss again and then go around again and then miss again. So it's just like it says in that video, it's just orbit is just a series of missing the Earth over and over and over again. So to give you a kind of a visual of that, oh, I've got this little demo here. You can see that's the Earth and that's the Sun. To scale, it would actually, that's the Earth and the satellite. That's what it would be to scale. So just so you know, we're looking at a cartoon because the distances between things in space are huge, right? So it's hard to get the right kind of scale. But if we look at this cartoon and think about it this way, and push play, our Earth is orbiting the sun, right? You can kind of see how the days are going. There should be 365 for it to do a whole way around, right? If we kind of say, okay, what's the force of gravity? Then, like we've talked about with circular motion, the force of gravity is going to be inward, and the force of gravity of one is going to be the same as the other. So every action, there is an equal and opposite reaction, right? So Newton's third law kind of at play happening right there. If I put the velocity vector, you can see that this thing has a constant velocity the entire time as it's going around the sun, right? And if you look closely, you're kind of think about it again, that the Earth is really just a projectile, and it just keeps missing the sun. So it goes around. So here it comes again. It's coming around, and it wants to fall straight down, but it's moving sideways, so it misses the sun. And then at the bottom here, it wants to fall straight into the sun, but it's moving sideways, so it's going to miss the sun again. And this is all that orbits are, right? And if we look at the Earth and our satellite going around here, it's the same situation. And this is why, if you're actually sitting up on the International Space Station, you're weightless, right? Everybody, like, you're on there, you can float around like you're in water type of a thing. But the acceleration due to gravity up there is still not zero. It's like, I forget what it is, like, it depends, it's like 2 meters per second squared, or it depends how high your orbit is, right? But the gravitational field strength up in that satellite is still quite a lot, right? It's still like it's not zero. So you're not floating around when you see astronauts in outer space because there's no gravity up there. They're floating because they're constantly falling, and that's the key there, right? They're the same way that you are weightless if you went skydiving. That's the same thing that they're experiencing the whole time. They're constantly just falling towards the Earth. They're falling and missing the Earth every time. I find that kind of neat, but anyway. So back to our sheet here. We've got the same type of thing happening up here right now with a cannon, right? If you're able to shoot that hard enough, it would come back and hit the cannon right in the back. All right. So satellites, and when we talk about satellites, it's not necessarily like like what you would think of as like the metal satellite. The other thing you're gonna see like on some data tables is that it'll say satellites of Mars. It's talking about moons, right? Satellites really means anything that's actually caught in the gravitational field of some body. So the moon is actually a satellite of Earth, you would say. Okay, now the math part of this. I was on the wrong sheet. Sorry. All right. So the way we're gonna do these ones is we are going to start off with FC is going to be something, and it has to be FC because it's going around the circle, right? We're really saying what's causing this force or centripetal force on this thing. Well, the only thing causing it, the only thing it could be with something orbiting is the force of gravity, right? So with these ones, we're going to say Fc is equal to the force of gravity. Then what we're going to do is replace Fc with what Fc is equal to. Fc is equal to mv squared over r. Fg, depending on like what they give us here, it's going to be g big M times m, or m1 times m2, same thing, over r squared. So with that, now we can see that m's cancel with m's. One of my r's cancel with that r squared. If I rearrange and solve for v, you end up with v is equal to square root of big G m over r. And remember, this is the big thing again, whatever's being orbited. Okay, so just looking at your formula sheet, this is the formula that we've just talked about there. And if you didn't get it before, the last one too is right there. So accelerate or gravitational field strength. Hopefully you found that one in the last one. All right. And here it says the equation above is not on your formula sheet. Well, lucky you guys, it is on your formula sheet. So, yeah. Something to note here, though, like this, what it's saying in the second one down here, that orbit doesn't depend on the mass of the satellite, right? The satellite is so so small in comparison to the force of the Earth that it actually doesn't matter. It doesn't matter at all about if you have like a super heavy satellite or a super light satellite. It's not going to matter. Okay, so example 1. What is the speed of orbit for a satellite orbiting Saturn if the radius of orbit is 6.43 times 10 to the 7? So we start off with Fc is equal to Fg, and Fc is equal to mv squared over r, yada yada, and we can solve for it by that. And when it says 6.64 times 10 to the 7, that's from the center, because it's saying that the radius of orbit is this. So that's not from the surface of the planet. That's from the center of the planet. All right. So again, for this one, you're going to have to start out with Fc is equal to Fg. Put in what you know here. And then instead of rearranging for V, you need to rearrange for R. And then you end up with 6.91 times 10 to the 6. But it says how far above the Earth is the satellite. So what you need to do, though, this R was from the center of Earth to the satellite. So what we need to really do is just minus the center of Earth. And that's going to give us our altitude. Now, little bit different, but pretty much the same concept. If a question says something about like the period of the satellite or the planet or something like that, what we're going to do now is the same thing, but instead of saying Fc is equal to mv squared over r, we are going to use the other one. So right here, 4 pi squared r m over t squared. So we're going to put that in place of Fc. So if you do that, it looks like this, right? And then rearranging for t is going to look like this. T squared is equal to 4 pi squared over gm r cubed. And actually, you know what? This one is on your formula sheet too, but I'm going to take it off. Actually, I'm going to take off both of those. So actually, you do need to rearrange these doing this method, right, of being able to rearrange a formula like that. I do want you guys to be able to do that skill. So I'm going to take off on my formula sheet. You've got these on the bottom here, right? I'm going to take that off. You won't have those anymore. Okay. Moving on. All right, so here's some more examples of the same type of thing. So look through those and see if you can do that. Yep, same type of thing. And then I'm going to pick up with Kepler's law in the second video. So that's it for that one.